Hello students, now I am going to solve the next numerical from chapter number 9, Light, Reflection and Refraction, class 10 science. So the question says, an object 5 centimeter in length is held 25 centimeter away from converging lens of focal length 10 centimeter. So here we have object height, that is 5 centimeter, and we have object distance, that is 25 centimeter, and we are going to use converging lens. So remember, our lens is converging lens. Then for this lens, the focal length is given, it is 10 centimeter. We have to draw the ray diagram and find position, size and nature of the image. So let's start solving. So I'll write here answer, and then first we have to write what all given values we have. So I'll write here given. So we have values, first one, that is object height. So I write here object height, and which is denoted by HO. So I'll write here HO, and how much we have? 5 centimeters. So I'll write 5 centimeters. Then if you see the question, we have object distance 25 centimeters. So I'll write here object distance. And what is the letter denoted for object distance? It is U, small u. So object distance is equals to 25 centimeter. We have to write it negative 25 centimeter, because if this is the converging lens, then this is the principal axis and our object will be present on the left side. So this side is left side and this side is right side. So we are going to keep our object somewhere here. So this left side, all the distances measured will be in negative, and right side all the distances will be in positive. So our object will be on the left side, therefore this we should write in negative. Then we have focal length. So I'll write here focal length, it is denoted by small f. So I'll write small f, and this is how much given? 10 centimeter. We have to write it plus 10 centimeter. Why plus? Because if you see the diagram, the rays which are going parallel to the principal axis will reflect and will meet on the other side of the lens. So like this, and this is called as principal focus, capital F, and this distance is called as focal length. And always focal length will be on the right side in case of converging lens, and therefore this should be positive. And the next we have to write, then what we have to find here, we have to find image height. So I'll write here image height. So image height I have to find out, and this is denoted by small v. So I'll write it question mark. With this we have to find magnification, we have to find height of the image also. So let me write first formula. So I'll write here according to lens formula. So we have two formulas like mirror formula and lens formula. Now this is the question for lens, so I'm going to use lens formula. So I'll write according to lens formula. And what is the lens formula we have? So the formula is, that is 1 by f is equals to 1 by v minus 1 by u. This is the formula which we have. Now in this formula we have to find out 1 by v. So I will rearrange. So I'll write it here all. 1 by v we will take it outside. So when it comes to the left hand side, negative is equals to, already it is 1 by u, that is negative, and if 1 by f, if we shift on right hand side, this also becomes negative 1 by f. I hope you understood. So what I did, I took this on the other side, so it became negative. Then this is already negative. I shift this on the right hand side, so this became negative. So this was the formula we got. Now negative sign we will remove it. So therefore I am going to get the equation like this. So final equation is 1 by v. If this is positive, then this side all signs will change. This becomes 1 by u plus 1 by f. So this is the final formula. Now substitute the values in this formula. 1 by v we have to find out is equals to, u is how much? Minus 25. So I'll write it down. Plus f is how much? 10. Now we have to find out the LCM of these two numbers. So LCM, so take here 25 and write here 10. Take any prime number, I'll take 5. 5 5s are 25, 5 2s are 10. 5 1s are 5, 2 as it is. And here 1 as it is, 2 1s are 2. So the LCM will be, that is 5 into 5 into 2. And therefore the LCM value will be 5 5s are 25, 25 2s are 50. So answer we got here 50. Substitute our value here. 1 by v is equals to, what is the LCM? 50. Now multiply this here, 25 2s are and 10 5s are will be. So write down here it is minus 2. You can see here there is a negative sign, and plus 5. So now write down on the other side. Let me clean this side. So now I'm going to get 1 by v is equals to minus 2 plus 5, and this we are going to get, that is we have to do the subtraction. So we get 3 and down it will be 50. Now this is 1 by v, actually reciprocal 8, and we have to find out v. So v will be 50 divided by 3. So now if I divide 50 by 3, what I'm going to get, see here 3. 3 1s are 3 first. So how much will remain? There will be 2, then 0 from the above. 3 6 are 18. Then again I'm going to get 2 here. This will be 0. Now here I'm going to take 0. It will be decimal. Then again 3 6 are 18. Then again 2 and again 0, and this will continue. So here our answer will be what? The answer will be 16.66. So I'm going to write V is equals to 16.66 centimeter. So here we got image distance, that is small v. Now see, I can write the positive value of v shows that the image is formed on the other side. See here, it is on the positive side. Therefore, I can write the sentence. Let me change the color. The positive sign of v value. So I wrote it here. The positive sign of v value shows that the image formed on the other side of the lens, that is on the right side. Now we will find out magnification. So I'll write here magnification. Magnification, we have two formulas. One is in terms of object distance and image distance, and the second one is in terms of object height and image height. So now I'm going to use the formula that is regarding distance. So m is equals to, I will write here image distance, and what is the image distance? It is nothing but, that is v. So I can write it here small v divided by, that is object distance, and object distance, what is the symbol for this? It is u. So I'll write here small u. So these value both we have, we can substitute. So what is the v? Just now we have calculated 16.66 centimeter, and what is u we have? U we have minus 25 centimeter. So let me substitute this value in the above formula. So now I will write the formula. M is equals to V by U. We know the value, so I'll substitute. M is equals to 16.66 divided by minus 25. So now see, this is in decimal, so I will shift the decimal on the right hand side by two places. So if I do like this, then the down at the denominator there will be multiplication of what? 100. So I'll do it here. So M is equals to 1666 divided by 25 into 100 it will be. See here I have written a negative sign, you have to write it. So now if I multiply this, I am going to get 1666 divided by minus 2500. Now this is the value which I got. Now this I have to divide first. So let me divide it here. So if I divide, I should write it here 1666, and here I should write 2500. If you see the inside number, it is small. I cannot divide it. So I'll take 0 here, and here I will take decimal. Now I will multiply. So 2500 into 6 if I do, I am getting 15000, that is 15,000. So here I'll get 0, 6, 6, 1 and 0 I'll get. Now again I'll take 0 here, and again I can do it the same way, that is 6 za 15000, and if I minus 0, 0, 6, 1 and 0, and same thing will repeat. So therefore I will write my answer. M is equals to minus negative sign we have to write, and then 0.66. So this we got here magnification. Now if you see here also there is a negative sign, so I can write here the negative sign. See here, very important, negative sign of M, or I can write of magnification. Magnification shows that the image is, this is very important, you should remember this trick. Image is inverted. Whenever the magnification value will be negative, remember always your image will be inverted. Now see, there is one more formula for magnification which is in terms of height, so that also we can do it. So I'll write here, but magnification is equals to image height. I'll write here image height. What is the image height formula? That is HI, and this is divided by object height, and object height symbol is what? HO. So I'll write both. So this is also one of the formula for magnification. So if you see the values, we know that HI we have to find out, we don't know, but HO is given, that is how much? 5 centimeter, and even just now we have calculated M value, it is minus 0.66. So these all we can substitute in the formula. So here I can write it like this, that is, once again I'll write it, M is equals to HI divided by HO, and I can write it like this also, HI is equals to M into HO. So what I did here, just I have shifted this here. Now substitute the values. HI is equals to, this is minus 0.66 and this is 5. Now just we have to multiply this. If I multiply this 0.66 into 5, if I do it, then 5 6 are 30, 3, 5 6 are 30 and 3 will be 33. This is 3 and as it is, so 1 2 3, so 1 2 3, here it will be the decimal. So our answer, that is the height of the image, will be minus 3.3 centimeter. Why minus? Because there is a negative sign, that you should not forget, you have to write it properly. So here the negative value of image height indicates that the image is inverted. This we have to remember. So I can write it here. Let me write the sentence. So here I have written the sentence, that is the negative sign of image height shows that the image is inverted, and the last, according to question, we have to draw the ray diagram for this. So if I draw the ray diagram exactly, I will understand the position, size and nature of the image. So this is our converging lines. Now I'll draw the principal axis. This is the principal axis. So let me write this is O optical center. Somewhere here I'll write F2 and somewhere here I'll write 2F2. This labeling you have to do it properly. Somewhere here on the same distance I'll write F1 and here I'll write 2F1. Labeling is clear. So here I have drawn my object. So I will label the object. I'll write here A and here I'll write B and this is of how much? It is 5 centimeter. Now some rays will come parallel and some rays will pass from the optical center. Let me draw the rays. So this is the ray which is going parallel to principal axis. Once it pass into the lens, it get reflected and pass from this F2. And the ray which is going from the optical center, it is going straight. After reflection, these both the rays are going to meet here. So I am going to get my image here in between F2 and 2F2. So let me draw this image. So this is my image. I will label it A dash and B dash. And what is the height of this? This is 3.3. So I'll write it here 3.3. Here I'm not writing any sign because you should remember if it is inverted, it is nothing but it should be negative. So here this distance it is 25 centimeter, that is object distance, and this distance it is 16.66. We have found it out, that is image distance. And this is the ray diagram for this question. I hope you will understand the explanation of this question, which I have explained very neatly and step by step. Practice this type of questions. If you practice it, then you can solve any question from this chapter, that is light, reflection and refraction. As we all know, one or the other question will be compulsory asked from for this ray diagram, that is light, reflection and refraction. It may be of mirror or it may be of lenses. The method of solving remains same. Therefore, practice more. And if you like my videos, share my videos with your friends and please consider subscribing my channel if you are getting little bit also help from these all the videos. Thank you so much.